Good day. My name is Edwin Jesu. I'm a DBA candidate at King's University College in Kuala Lumpur, Malaysia. It is my pleasure to present this paper at the 8th International Multidisciplinary Academic Conference. The paper is titled Swarm Intelligence as an Organizational Governance Model, a conceptual framework for decentralized decision-making in complex environments. Over the next 15 minutes, I will walk you through the theoretical arguments, the framework we have developed, its practical implications, and where this research is heading. Let me start by describing the problem. Most organizations today still operate through hierarchical governance structures that concentrate decision making authority at the top. And while hierarchy has served us reasonably well for much of the 20th century, the environment we now operate in has fundamentally changed. Jedinak and colleagues writing in 2021 described today's environment as VUCA: volatile, uncertain, complex, and ambiguous. In VUCA conditions, hierarchies create three compounding problems. First, decision bottlenecks. When authority is concentrated at the apex, every significant decision must travel up the chain and then back down before action can be taken. This result is that organizations are slowest precisely when speed matters most. Second, information asymmetry. Frontline agents, the people closest to customers' signals and real time conditions, hold the most operationally relevant knowledge. But in a hierarchy, that knowledge gets filtered, compressed, and often lost before it reaches those with the authority to act on it. And third, and the most importantly, suppressed intelligence. Hierarchies do not just slow things down, they actively lock out the distributed knowledge and adaptive capacity that exists throughout the organization. The intelligence is there, the system just cannot access it. So, the question I'm asking in this paper is there a better design logic? One that can coordinate complex organizations without requiring centralized control. The answer I'm proposing comes from an unexpected place: biology. Swarm intelligence is the study of collective behavior in decentralized, self organized systems. The defining characteristics of these systems is that individual agents, each following simple local rules, produce sophisticated global outcomes without any central planner, without any blueprint. Three natural examples illustrate this beautifully. Ant colonies have no project managers. No ant knows where the food is before others find it. Yet, through stigmergic trail coordination, depositioning, and following chemical signals in the shared environment, the colony solves complex optimization problems that computer scientists have spent decades trying to replicate. Bird flocks produce those breathtaking murmurations, thousands of birds moving as a single fluid entity. The entire behavior emerges from just three local rules: align with your neighbors, move towards them, avoid colliding with them. No bird is giving orders, and neural networks, the basis of modern artificial intelligence, process information through distributed signal exchange, not central computation. No single neuron understands the image. The understanding is collective. The key insight across all three examples is this: complex adaptive behavior emerges from simple local rules, no blueprint required. My argument in this paper is that if nature can organize systems of extraordinary complexity through distributed intelligence, then we should ask whether those same design principles can be translated into organizations. From the swarm intelligence literature, I have identified five core properties that characterize how these systems work, and that I propose can serve as a design grammar for adaptive organization. First is stigmergy. Agents in swarm system coordinate through shared environmental signals, not through direct communication with one another. There is no need to call a meeting. The signal is already in the environment, readable by all. Second, self-organization. Ordered, coherent structures emerge from local agent interactions without anyone directing the process from above. The structure is a consequence of the rules, not a product of control. Third, emergence. The collective capabilities of the systems exceeds what an individual agent can contribute. The intelligence is not designed in from the top. It is a condition-enabled property. You create the conditions and intelligence emerges. Fourth, simple rules. Complex adaptive behavior arises from agents following a minimal rule set. Reynolds in 1987 worked on flocking, which underlies every visual effect simulation of crowds you have seen in a cinema, demonstrated that three rules were sufficient to replicate the entire flock. And fifth, adaptive feedback. Agents continuously incorporate real-time signals into their behavior. The system is not just reactive, it is continuously self-updating. These five properties are not curiosities. Together, they are a design grammar for adaptive collective behavior. and they are the foundation of the framework I will now introduce. The Swarm Governance Framework, which I call the SGF, is built on a single principle: governance by environmental signal, not managerial directive. Rather than issuing instructions and waiting for compliance, the SGF proposes that organizations should design the signal environment and allow coordination to emerge from it. The operational model within the SGF is called STRUM. STRUM is a 5-element design specification, and each element maps directly to one of the swarm properties we just discussed. S stands for signal, T for trust, R for resonance, U for unity, and M for measure. Let me take you through each one of it. Signals corresponds to the swarm property of stigmergy. In an organization, this means replacing private communication channels with shared environmental logging, a system where every agent deposits readable signals into common environment. Think of it as replacing email threads and closed meetings with ambient shared signal environments. The design rule is information should flow to where it is needed most, not upward, to where authority lives. Trust corresponds to self-organization. In governance terms, this means distributing decision rights to the lowest effective level without requiring central authorization for every action. Approval chains are replaced by clearly defined decision boundaries. Agents are trusted to act within those boundaries without checking upwards for permission. Resonance corresponds to emergence. This element is about making collective intelligence visible. It requires building aggregation layers, mechanisms that surface patterns from the distributed signals in the environment. The design implication is that we should reward signal surfacing over directing. The intelligence is already in the system. Resonance makes it legible. Unity corresponds to simple rules. Rather than policy manuals running to hundreds of pages, Unity proposes a minimal governing rule set, somewhere in the range of 5 to 9 principles, that constrains agent behavior without prescribing it. Agents know the boundaries. Within those boundaries, they have the discretion to act, and measure corresponds to adaptive feedback. This element closes the loop, designing feedback mechanisms at the agent, team, and system level that allow the organization to self-evaluate and self-update. The organization becomes not just responsive, but continuously self-improving. Together, these 5 elements form a complete governance design specification. And critically, as I will return to shortly, they also map directly onto AI agent configuration parameters. So how does swarm governance actually differ from what most organizations do today? In traditional hierarchical governance, coordination happens through managerial directive. Authority is concentrated at the apex. Information travel upwards, filtered at each level, and adaptation is planned in advance. And emergence, the very property that allows complex systems to self-organize, is actively suppressed because it cannot be predicted or controlled. In swarm governance through the SGF, coordination happens through environmental signals. Authority is distributed to agents at the appropriate level. Signals are ambient and shared. No filtering, no loss. Adaptation is continuous and self-organized. And rather than suppressing emergence, the framework actively designs for it. This is not a minor variation on existing governance model. It represents a fundamentally different design logic, one that is not derived from the assumption that control produces order, but from the observation that conditions produce emergence. Now, what does this mean in practice? The first implication concerns digital transformation. Most organizations have made significant investments in enterprise platforms such as ERP systems, shared dashboard, collaboration tools. The conventional framing is that these are efficiency tools. The SGFs reframes them as signal environments. A shared project dashboard is not just reporting infrastructure. It is a stigmergic signal environment. Every update, every status change, every comment is a signal deposit that other agents can read and respond to. The purpose of digital infrastructure shifts from improving efficiency to enabling ambient coordination. The phase deployment recommendation is to start with signals. Deploy AI in read-only mode first, not as a decision maker, but as a signal reader. Build agent literacy in what signals are available and what they mean before you begin redistributing decision rights. The second implication is perhaps the most novel. Strum's 5-element map directly onto AI agent configuration parameters. Signals become logging and deposition functions. Trust becomes decision routing logic. Resonance becomes the pattern detection layer. Unity becomes constraint and rule parameters. And measure becomes self-update and evaluation protocol. This means Scrum is not just a governance philosophy. It is a machine-readable design specification, one framework, one design language, both human governance and AI agent configuration. Given that wholesale transformation of organizational governance is neither feasible nor advisable, the SGF recommends a phased deployment strategy across four phases. Phase one is signals first. Before redistributing decision rights, build the signal environment. Deploy AI in read-only mode. It surfaces signals, it detects patterns, but it does not decide. This phase is about building organizational literacy in what distributed signals actually look like. Phase two is build trust. Once the signal environment is established, begin redistributing decision rights to the lowest effective level. Replace approval chains with clearly defined decision boundaries. This is the phase where agents begin acting on signals rather than escalating them. Phase 3 is establish unity. Articulate the minimal governing rules out, the 5 to 9 principle system that will anchor the distributed system. This is not a policy manual. It is the attractor that provides coherence without reimposing hierarchy. And phase 4 is close the loop. Activate measure and resonance. Design feedback mechanisms at every level. Enable the system to self-evaluate. This is where the organizations becomes genuinely adaptive, not just decentralized, but self-improving. The key practical lesson is this: do not try to implement swarm governance all at once. Build it layer by layer. Each phase creates the foundation for the next. I want to be transparent about the limitation of this work because intellectual honesty is part of what makes frameworks credible. First, the biological to social translation challenge. Human agents are reflexive, politically motivated, and status conscious. They do not simply follow local rules the way ants or birds do. The extent to which swarm design conditions operate differently in social organizations requires careful empirical investigation. The biological analogy is a productive starting point, not a direct transplant. Second, empirical validation is needed. Strum proposes 5 elements as necessary and sufficient conditions for swarm governance. That claim requires operationalized measures tested across diverse organizational contexts. The framework is proposed here as a conceptual architecture, not yet a validated empirical model. Third, contingency conditions. The framework does not yet specify when swarm governance outperforms alternatives. Not every organization in every environment should govern like a swarm. Future work should locate the SGF within a complexity contingency model, drawing perhaps on Snowden's Seinfeld framework. I should note that empirical validation is already underway at the doctoral level through case studies, measurement instrument development, and an AI coordination prototype. This conceptual paper establishes the framework, the empirical work will test it. Let me close with the 3 takeaways. First, the SGF is biologically grounded. The framework draws its design principles from swarm intelligence, a literature built on decades of empirical observation of how complex systems actually organize themselves. This is not a metaphor. It is a principled translation of established natural phenomena into an organizational design logic. Second, Strum is a dual function specification. It is simultaneously a governance philosophy and a set of 5 accessible design conditions. It is normative, it tells you what governance should value, and it is prescriptive. It tells you what condition to design for. That combination is what makes it actionable. Third, Scrum provides a unified AI logic. Its 5 element maps directly to AI agent configuration parameters. This makes the SGF uniquely suited to the challenges most organizations will face in the coming decade. Governing hybrid human AI teams through a coherent unified design framework rather than bolting AI onto legacy governance structures. The governance challenge of our time is not how to control complexity. It is how to design conditions in which collective intelligence can emerge. The swarm governance framework offers one principal answer to that challenge. Thank you very much for your time and attention.